AMC8 2015 Problem 1. How many square yards of a carpet are required to cover a rectangular floor that is 12 feet long and 9 feet wide? There are 3 feet in a yard. By drawing the rectangle, this is 9 feet and this is 12 feet. This is 3 yards in 9 feet and 4 yards in 12 feet. Altogether, it's 12 square yards. So answer is A. Problem 2. Point O is the center of the rectangular octagon A, B, C, D, E, F, G, and X is the middle point of the side AB. What fraction of the area of the octagon is shaded? We connect OA, and this is 1/2. And this white area is 1/2 of the 1/8, because each sector is 1/8 for the regular octagon. So the area is 7/16. Problem 3. Jack and Jill are going swimming at a pool that is 1 mile away from their house. They leave home simultaneously. Jill rides her bicycle to the pool at a constant speed of 10 miles per hour. Jack walks to the pool at a constant speed of 4 miles per hour. How many minutes before Jack does Jill arrive? We draw a speed, distance, timetable, and the distance is 1 mile, and the speed for Jill is 10 miles per hour, and the time it takes is 1/10 hour, also equals to 6 minutes. And for Jack, his speed is 4 miles per hour. It takes 1/4 hour, equals 15 minutes to complete the same distance. So 15 minus 6 equals 9, and Jill arrives 9 minutes before Jack. Answer D. Problem 4. The Centerville middle school class team consists of 2 boys and 3 girls. A photographer wants to take a picture of the team to appear in the local newspaper. She decides to have them sit in a row with boys at each end and the 3 girls in the center. How many such arrangements are possible? So in the middle are girl, 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 and on the side is boy and boy. Because boy is limited to the 2-side position, so for those position boy 1 and boy 2, we have 2 factorial ways to arrange them. And for girl 1, girl 2, girl 3, we have 3 factorial ways to arrange them. They follow multiplication rule. So that's 2 multiplied 6, equals 12. There are 12 ways possible to arrange the boys and girls. Problem 5. Billy's basketball team scored the following point over the course of first 11 games of the season. If his team scored 40 in the 12th game, which of the following statistics will show an increase? Score 40 is a low score, will be have put in the front of all the score, so it will lower mean for sure. It's also going to lower median, and it's not going to change mode. For mode is 58. The mid-range will also decrease because and the only thing range will increase is the range, because 73 minus 40 equals 23 is bigger than 73 minus 42, the original range. Answer A. Problem 6. In triangle ABC, AB equals BC equals 29 and AC equals 42. What is the area of ABC? So this obviously is an isosceles triangle. B, A, B, and BC both equals 29 and AC equals 42. If we drop a height from B toward AC, and that will bisect side AC into 21 and 21, and the height can be calculated using Pythagorean theorem with 29 square minus 21 square and square root, and use the difference of square formula. That's 29 plus 21, 29 minus 21, that's equal to 50 multiply 8 equals actually 25 multiply 16 and equal to 5 multiply 4 equals 20. So the height is 20, and the area of ABC is 1/2 of 42 multiply 20 equals 420. Answer is B. Problem 7. Each of two boxes contains 3 chips numbered 1 to 3. A chip is drawn randomly from each box, and the number on the 2 chips are multiplied. What is the probability that their product is even? So we're going to list a complete matrix of the result, and that's 1, 2, 3, 1, 2, 3. We're going to use each number's remainder with 2. So this is 1, 0, 1, 1, 0, 1, and the odd and even depend on if their product is odd or even, and we can tell that there are 5 0 out of a total 9 possibilities, so 5 over 9. Problem 8. What is the smallest whole number larger than the perimeter of any triangle with a side of length 5 and a side of length 19? So this integer is the smallest one, but larger than the perimeter of any triangle. So we should try to construct a triangle as big as possible in terms of perimeter. And the largest possible way is trying to stretch 5 and 19 almost on the same line. Then the longest side will be very close but not equal to 19 plus 5. So the perimeter of this triangle going to be less than twice multiply 5 plus 19 equals 2 multiply 24 equals 48. So 48 is the smallest whole number larger than the perimeter. Answer is D. Problem 9. On her first day of work, Janabelle sold 1 widget. On day 2, she sold 3 widgets. On day 3, she sold 5 widgets. And on each succeeding day, she sold 2 more widgets than she had sold on the previous day. How many widgets in total had Janabelle sold after working 20 days? So if we label the date and also label the amount of the widgets she sold at 20 days, she going to sold, and there's a formula 2n minus 1, and that's going to be 39. And we observe the leading total. That's 1 square, that's 2 square, 1 plus 3 equals 4, and that's 3 square. So follow this pattern, it's going to be 20 square on the 20th day. So the answer is 400. This can also be solved by adding it up reverse way. If we rearrange the whole number, thus reversely arrange 39, 37, and all the way to 1, and then if we add it up, and vertically speaking, each item each pair will add up to 40, and each line add up is the total, and this is also total. So we have 20 or 40 add up to 2t, and 20 multiply 40 equals 2t, and t equals 400. Problem 10. How many integers between 1000 and 9999 have 4 distinct digits? For their total the first digit, we have 9 ways of picking. We can pick 1 to 9. For the first digit is the most restrictive digit. Then after we picking the digit on the thousand and on the hundreds of position, we still have 9 ways, because we have to take away the selection already we make on the 1000th position. And then on the 10th we can have a selection. We have 10 has to minus 2, because we already picked 2 number. We have to avoid the correlation with 1000 and 100th position. Then on the ones we have 7, so multiply those together. 81 multiply 56. B is the answer. Problem 11. In the small country of Massland, all automobile license plates have 4 symbols. The first must be a vowel, A, E, I, O, U. The second and the third must be 2 different letters among the 20 non-vowels. And the fourth must be a digit, 0 through 9. If the symbols are chosen at random subject to this condition, what is the probability that the plate will read AMC8? So AMC8 itself has only 1 choice. So the numerator is going to be 1, and the denominator is the total possible arrangement of letters for the license plate. The first position is we have 5 choice, because we have 5 vowels to choose from. The second and the third position, we have 21 and 20, because they have to be 2 different letters. And the fourth position has to be a number that we have 10 choice. So this make a 100, this make is 210. So the answer is going to be 1 out of 21,000. B. Problem 12. How many pairs of parallel edges, such as AB, GH, EH, and FG? So when we observe the cube, we have horizontally we have 4 lines parallel, and vertically we have 4, and horizontally going depths we have still 4 pair. We altogether have 12 edges. So each 4 pair we can choose any 2 to make a pair. So it's 4 choose 2 and multiply 3. That's equal to 3 multiply 4 multiply 3 divided by 2 multiply 1, and that's 18. Problem 13. How many subsets of 2 elements can be removed from the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so that the mean average of the remaining number is 6. So 6 is the average, 6 is also the median. So if we take away two numbers added up to 12 in a pair, we will be able to keep the average the same. And we have 111 first pair, 210 second, and 3, 9, 4, 8, 5, 7. We altogether have 5 pair. Answer is D. Problem 14. Which of the following integers cannot be written as the sum of 4 consecutive odd integers? So let's try to investigate for consecutive odd integer like 1, 3, 5, and 7. The average will be 4. And so the average and the median will be a even number because it will be an even number. Add 1 and minus 1 will make a consecutive odd number, then expand 2 more. It's going to get the 4 rest number. So let's try to calculate the median or average of each 4 consecutive number. And this is going to be 4. That will work just as this one. And then this one will be 10. They're also going to work. This is going to be 18. And this 25. And this is going to be 50. So 25 will not work because if the median is 25, I cannot make 2 consecutive number of odd integer. So it's going to be 25 plus 1 going to be 26 and 24. Or if I add 2, that's going to be 27 or 23. And 27 and 23 are not consecutive. And problem 15. At Weiler Middle School, 195 students vote on 2 issues in a school referendum with the following result. 149 vote in favor of the first issue and 119 vote in favor of the second issue. If there are exactly 29 students who vote against both issues, how many students vote in favor of both issues? So this problem is actually a Venn diagram, 2-category Venn diagram problem with 2 issues. And we know 29 vote against both issues. So 29 is outside of both circles. This is issue 1, this is issue 2. And issue 1 have 149 votes, including overlapped position 119, and there are total of 198 students. So if we 198 minus 29 going to be the scope of both circles add together. $169 will be including both circles plus their overlap. We're going to add 149 to 119. 269 include double counted overlapping, and we minus 169, that's going to be 99. So answer is D.